Let's talk about backtracking. First, we're going to talk about the n queens problem. Here it's the 4 queens problem. In the 4 queens problem, we have a 4x4 chessboard, and that's what you're looking at now. And we can place queens on the chessboard. And as we do, we're trying to place 4 of them so that no 2 queens are attacking each other. Note that a queen can attack on its row, on its column, and on either of 2 diagonals. So for instance, this queen here can attack on this up and down diagonal up to the right, and also down to the right on this diagonal, as well as this row and this column. The 4 queens problem is to place 4 queens on a 4x4 board, and 8 queens is on an 8x8 board to place 8 queens, and so on. Okay, so first let's talk about how we could just mechanically, methodically, slowly solve this. We'll just try every possible combination. And what we'll do is in each column, we'll place a queen in each possible place. And then when we're done, we'll check if we solved the problem. So we'll start with a queen here, and then that's the first column. In the second column, we'll start here, third here, fourth here. Since we made it all the way across, we say, does this solve it? The answer is no, of course not. All of the queens attack each other. So we'll try this one, no, this one, no, and this one, no. Because we tried every possibility in this column, we know that these 3 columns can't be like this because none of the possibilities in the 4th column satisfy the problem, solve the problem. So we go back a column, pick this up and try here. Then we'll go all over again. This one. Of course, none of these are going to work. Back a column, pick this up and go here. And once again. All right, so this seems silly because no matter what we're doing way out here, the problem is right at the beginning, we are doomed. We will never find a solution no matter what we do in these columns, given what's happened in the first 2 columns. But the naive solution just keeps exploring every possibility. So backtracking is much cleverer because what we do instead is when we place this first queen in the first column, in the second column we'll place a queen here, but immediately we'll check, hey, is that a legal possibility? Does it, the problem has what we call constraints. Constraints don't allow certain states. This is a state. And in this case, for n queens, no 2 queens can attack each other. That's a constraint. These 2 queens are attacking each other, so this state violates the constraints. And because of backtracking, we immediately stop. And we know that this cannot work no matter what we do in these columns. So we pick this queen up. We go here and try this one. Well, it violates too. So we pick this up and go here. This one seemingly works, so we go column over, here, no, here, no, here, no, and here, no. So we pick this up. Since this column failed, we go back a column, pick up and go here. Works? Nope. This one seems to work, so we go here, no, 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 no. So we pick this up and then go here, no, and here, no. Go back and pick up, when you're done with a column, that means that entire column failed, so you go back, pick this one up and go down here again. Over here, no, 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 yes. Go next column over, yes. Go here, no, no, yes. Oh, we finished the board and we have solved n queens. So what's interesting here is even though, sure, we had to still explore the space, we had to try things, and when they failed, we had to back up, which is backtracking. Because we are applying the constraints as we go, because when we got here, we knew for sure we had to stop and no longer consider anything further for any more columns, that makes an enormous difference in most cases in the runtime, as we will see with the examples that we'll consider next. But this is the basic idea of backtracking. The basic idea is you start in some state trying to solve some puzzle or a problem. You have a goal state you're trying to get to. You have some constraints that you want to apply, and you keep making moves and then check if the constraints are violated. And if they are, you undo the move, you backtrack. And that's the basic idea of backtracking.